The fringe width or bandwidth in an interference pattern is understood in terms of the following set of equations. Please look at the small diagram which has been provided. Sin theta is approximately equal to theta, which is equal to y by d, where y is the distance of the point P at which the effect of the waves is felt. Capital D is the distance between the plane of the slits S1 and S2 and the position of the screen. So, y by capital D is equal to delta x by small d, where d is the distance of separation between the two slits, or in other words, it can also represent the two coherent sources. When delta x is equal to n lambda, bright bands are formed. When delta x equals 2n minus 1 lambda by 2, dark bands are formed. The bandwidth or fringe width beta equals capital D by small d into lambda. The angular fringe width theta 0 is equal to beta by capital D, which is equal to lambda by small d. When a transparent sheet is introduced in the path of one of the interfering light waves, then the lateral shift that is produced on the screen is given by a formula y0 equals y prime minus y, which is equal to capital D by small d delta x minus of capital D by small d into delta x plus mu minus 1 into t, which is equal to beta by lambda into mu minus 1 into t, where mu is the refractive index of the transparent sheet and t is the thickness of the sheet. In the case of colors of thin films, it is found that when white light is incident on a soap film or on a thin sheet of oil, then different colors are produced. The formation of these colors is once again due to interference of light waves. When light waves are incident on a thin film of thickness T and refractive index mu, then the condition for constructive and destructive interference still remain the same, but there is what is known as dissimilar reflection. Therefore, the path difference between the two interfering waves can be given by a general formula 2 mu t cos r equals n lambda, where r is the angle of refraction at the interface between air and the given transparent medium. When 2 mu t cos r equals n lambda, this becomes the condition for destructive interference. On the other hand, when 2 mu t cos r equals 2n minus 1 lambda by 2, then it gives the condition for constructive interference.